Hi, my name is Evelyn Watts. I am an assistant professor and seafood extension specialist at Louisiana State University Agricultural Center and the Louisiana Sea Grant. One of the research focus areas that I work is improving seafood quality. As you know, Louisiana is a big producer of seafood, and we are working locally with fishermen and processors to improve their seafood quality. As you know, seafood is one of the main sources of protein around the world, and the consumption continues to grow annually. Actually, the majority of seafood is consumed in Asia, followed by Europe and then the United States. However, seafood presents a big challenge due to its high perishability, giving it a very short shelf life. And this is basically because of the high unsaturated lipid in its composition, in addition to the presence of psychrophilic bacteria. And even though there have been many techniques that have been developed to maintain the food quality and extend the shelf life, there's still a big proportion of seafood that still markets wrapped in a piece of newspaper. In my presentation, I will be talking a little bit about seafood quality and the main factors that affect the quality and shelf life. And then I am going to transition a little bit on preservation techniques, specifically with some packaging technologies. And then I will be sharing some data of some studies that we had complete at my lab. So first, let's talk about seafood quality. The seafood quality is determined by physical, chemical, and microbiological characteristics that will directly affect color, texture, and flavor that are the drivers that control purchase intent. So the main contributing factors to the loss of quality are going to be bacterial growth, fat oxidation, and enzymatic attack. So we need to understand these factors to be able to extend the shelf life of seafood and improve the quality over time. So when we talk about bacterial growth, live fish is normally considered to be sterile, but it has microorganisms on their surface and in their intestinal tract. For the most, fish that come from temperate waters are going to be covered or going to have a flora of psychrophilic bacteria such as Pseudomonas, Moraxella, Vibrio, Aromonas. On the other hand, fish from tropical waters are going to be or have non-psychrophilic bacteria. Therefore, chilling properly will help to reduce the multiplication of this bacteria. Then, when we talk about fat oxidation, basically we know that fish have a high composition on unsaturated lipids that are very prone to this lipid oxidation. So it will decrease quality and yield a very short shelf life. In addition to the high content of unsaturated fats, fish contain a compound called 3-methylamine oxide that is also known as TMAO. This fat decomposes to form 3-methylamine, TMA. That is what gives fish that undesired fishy aroma. In addition to this, we have the enzymatic activity that also plays a role during fish spoilage. So appropriate chilling, refrigeration, and freezing will be key elements to reduce this enzymatic activity. This is done on boat or at the dock. In addition, we also have that fish typically have a higher pH compared to red meat, so that also makes it more prone to spoilage. And we need to remember that fish is mostly market fresh. So even though multiple preservation methods are being used to extend seafood quality and shelf life, such as cold chain management, antimicrobial interventions, packaging, freezing, proper storage, we do need to remember that the most important part of all these factors is to chill the product immediately upon harvesting. Bacterial growth. When we talk about bacterial growth, it is important that we understand how bacteria multiply. It's going to start with a lag phase, followed by a logarithmic phase, a stationary phase, and death phase. So bacteria, when they are in a new environment, they will need some time to adapt. Once they adapt, they will start multiplying pretty fast and is going to grow exponentially. That this is the log phase. In this phase, if we provide the optimum conditions, bacteria are going to multiply or complete a full reproduction cycle within 20 or 30 minutes. Then it's going to go to a stationary phase and a dead phase. But then we're going to have new bacteria starting from the lag phase. So basically what we want to do is control the different factors that bacteria need to multiply so we can slow down this process. So let's talk about these factors. So bacteria are living things. So just like humans and other living organisms need food to be able to multiply. Well, seafood is probably a really good source of nutrients for bacteria, so there's nothing we can do about that. But there are other factors such as acidity, pH. Bacteria need a neutral pH to grow, and seafood has a slightly below neutral pH. So it's also a good environment for acidity. But then we have time and temperature. Okay, so if we provide an optimum temperature for bacteria to grow for enough time, we're gonna go through that log phase really quick. That's why we want to chill fish upon harvesting so we don't allow optimum temperature or time for bacteria to grow. Then let me jump to moisture. Moisture, well, fish is very high in moisture, so yes, it is a good source for bacteria to grow. But lastly, I do want to talk about oxygen. So some bacteria will grow in the presence of oxygen, and other bacteria won't be able to multiply in the presence of oxygen. Spoilage bacteria need oxygen. So that's where we focus most of the new technologies in packaging to control oxygen in the package to inhibit the multiplication of spoilage bacteria. Even though my presentation today is about packaging, I always like to spend one slide of my presentation to remind the industry about the first barriers that we have to slow down bacterial growth, which is a proper chilling at the boat and followed by a proper cold chain management program through processing and distribution. It doesn't matter how nice your packaging is if your final product is gonna be of bad quality. So really quick, when we are catching our fish, depending the waters that we are catching, the fish is gonna be 20 degrees or higher. So we need to chill that product as quick as possible. And when we talk about chilling, is dropping that temperature down close to 0 degrees. Once we accomplish this, the product will be ready for freezing. You don't want to freeze a product that is hot. You want a chilled product. So you have a more efficient freezing process. But when we talk about freezing, we usually think about water. And we all know that water freezes at 0 degrees. However, the water that is in the fish is not pure water, it has other elements. So it takes a lower temperature to freeze. This is going to start freezing at -1 Celsius degrees. But it's not going to be until we achieve -25 that 90 to 95% of the water in that seafood is going to be completely frozen. It is important that we pass this stage from -1 to -5, that is the freezing zone or critical zone, as quick as possible to maintain the quality of the seafood. And I don't want to spend more on this. We can have actually another presentation just on freezing. It's just lots of fun. But now let's move back into packaging. Historically, packaging was used as a way to contain the product and to protect it from contamination. It was also used to ease transportation and provide a uniform measure of the contents. However, over time, this has transitioned and we are using packaging as an advertising and branding opportunity. Codex Alimentarius defines packaging as food is packed to preserve its quality and freshness, add appeal to consumers, and to facilitate storage and distribution. So, the primary objective of packaging is to protect the product to preserve quality and safety. However, some other values to packaging are to make a product more appeal and convenient to the consumer. Many describe the four primary functions of packaging as containment, protection, convenience, and communications. Containment is usually overlooked because it is obvious. Most products need to be contained to move them from one place to the other. However, containment prevents product losses and protection from unwanted contamination and basically facilitates the process of storage and distribution. Then protection, well, this one is more obvious, but even though seafood is being chilled, it is among the most perishable products as they are known. It has high moisture and it has a relative neutral pH. So basically, packaging aims to protect the product from the environment. However, in recent years, new technologies in packaging look into control the environmental conditions within the package to reduce the decomposition through inhibition of the bacterial growth and enzymatic activity. And I will go into more detail later in my presentation. Then we have convenience. And this is not just on how the product is prepared, like if it's a whole fish, fillet, breaded portions, etc. It also includes the contribution of the package and its functions. So, how a package is easy to open, resealable, and the portions are individually wrapped, that's going to make the product more convenient and pleasant experience to the consumer. It is important that we keep in mind convenience to our clientele, either if it's a retail store, the final consumer, or institutional. And then communication. Many processors understand that packaging needs to protect the product, but we also need to remember that packaging plays a very important role in selling. The consumer more interested than the packaging is the product. So if you have a chilled product, the visibility is very important. You want to have a dry, clean, transparent film that's going to give a very good first impression. The consumer wants to inspect the product for quality as much as possible. The information that you have on your label, it can either be pre-printed on the label or it can be just a sticker that is attached to the product. You can use that as a branding or marketing, so you want to include your brand and your logo. The information on what is contained in the packet is very important. Talking about what seafood product you're packaging, what product form, if it's in a sauce, if it's marinated, breaded, all the ingredients. All this is very important information, especially with allergens. Other things that you can include into your packaging that you can use for communications are the intended use. Including a recipe is always a good idea. Include nutritional information and any other local government requirements that you have. So remember earlier when I was mentioning about the different factors that bacteria need to grow, and I mentioned oxygen. So one of the recent technologies on packaging is controlling the oxygen in the package. So in this way, we are going to classify packaging in two different groups. oxygen permeable packaging, and reduced oxygen packaging. And basically, the difference between these two technologies is based on the type of film that we are using, if it allows or not the transmission of oxygen. The United States Food and Drug Administration, in their seafood hazard control guide, has defined as oxygen permeable any type of packaging material that allows exchange of oxygen from inside and outside the package at an oxygen transmission rate of 10,000 or more cubic centimeters per square meter per 24 hours at 24 degrees. Commercially, you might have heard about a 10K film. This is a brand that is available in the market. However, there are many other variants of this one. In general, we can say that single layer polyethylene or PVC or polypropylene films are considered oxygen permeable materials. On the other hand, when we have oxygen transmission rate or OTR below 10,000, then we are talking about reduced oxygen packaging or ROP. Basically, this packaging prevents oxygen from going into the container. Some examples of this packaging are the old-fashioned double seam can, like the canned salmon or canned tuna. We also have glass jars and more recently heat sealed plastic containers that are very popular nowadays with shelf stable tuna. In addition, we have vacuum pack, that is when we are using oxygen, non-oxygen permeable films. And then we have modified atmosphere packaging, MAP, and control atmosphere systems. During my presentation, I won't be talking about the first three because these are for shelf-stable products, and today I'm basically talking about fresh refrigerated products that will be using any of these three: vacuum packing, MAP, or control atmosphere systems. Vacuum packaging is probably one of the cheapest and most common types of reduced oxygen packaging used, especially among small processors. And basically, you are removing the oxygen available in the package, and you do this applying a vacuum force. This will result in the removal of the oxygen available. Um, Depending on the type of bag that you use, this will result in a reduced oxygen or not reduced oxygen package. And usually the barriers for vacuum packing, depending on the bag, will go from 15K or lower. I do want to bring your attention on vacuum packing that there is a direct relationship between the amount of vacuum and the quality of the product. Even though vacuum packing will result in a very little or not headspace, which is good when we want to freeze a product because it will reduce the freezer burn. If you apply a very high vacuum, you might be compromising the quality of your product. And this will basically depend what you are packing. For example, in this picture, I'm showing you crab meat. Crab meat is very sensitive to pressure. So yes, you want to have a tight pack. However, if it's too tight, your drip loss or exudate will be very high. So you probably want to evaluate your equipment and your product to get the best balance between vacuum and quality. Depending on product, for example, crawfish tail meat is not as sensitive to vacuum. So everything depends what you are packaging. Now, modify atmosphere packaging, or most commonly known as MAP. This technology's principle basically is to replace regular air in the package with a fixed gas mixture. Depending on the technology that you are using, some machines will first remove the oxygen by vacuum. Other ones might just replace the headspace with a fixed gas mixture. Basically, in this technology, what you are doing is to remove the oxygen from the package to slow fat oxidation and microbial activity. And even though a fixed composition of gas is introduced in the package, after the package is sealed, you lose any control on the composition of that head space. And basically, this is because of the changes in microbial activity. The efficiency of this process of the modified atmosphere packaging, it will depend in the packaging machinery, the package itself, and the physical properties of the package. Modified atmosphere usually is considered a reduced oxygen packaging because the film and tray that we use for this allows very little transmission of gas from within the packet and to the package. It is important to remember not to confuse this technology with controlled atmosphere packaging that I'm going to talk about later. Uh, One of the main advantages of modified atmosphere is that depending on the product that you are packaging and the microbial load, you can increase shelf life in a 50 to 400%. Different gas compositions have been used for modified atmosphere packaging. Here in this slide, I'm going to focus in the two most common ones. In any of them, you're going to use nitrogen as your carrier gas and then carbon dioxide. Carbon dioxide is recommended between 35 to 45% because it has been found that extremely higher levels of the gas will not result in a significantly higher or more shelf life. However, it will result in the acidification of the product, resulting in flavor and color changes. And then an effective gas combination will vary according to the fish species, using less oxygen for fatty fish to prevent the fat oxidation. Although currently some countries don't allow the use of carbon monoxide, it is being used in some countries. And basically this is used to produce a attractive red or pink color that is caused by the oxygen. And mostly this is applied into tuna, but the reason that it has been banned in some countries is because it could be misleading and you can have a fish that is already spoiled and still seem as fresh due to that really bright pink color. Recently, we published the manuscript Laitram Shelf Life Comparing Three Packaging Technologies. In this study, we aim to compare four different packaging in the shelf life of Laitram fillets. We compare an oxygen permeable bag that you will see here in green, vacuum pack in blue, and two different modified atmosphere combination. The first one was a two-gas mixture of nitrogen 70% and carbon dioxide 30%. And the second one, it was a three-gas with nitrogen 30%, carbon dioxide 40, and oxygen 30%. Here on the left side, we have aerobic plate count. If you see actually the oxygen permeable and vacuum pack past the 6 log recommended limit, day 16, and they continue to go higher at day 20. On the other hand, we did have significantly lower counts for the modified atmosphere packaging. We didn't see any difference between them two. And then here on the right side, I have the mold count. The same thing, if you see at day 12, we had a significantly higher count in mold for vacuum pack and oxygen permeable compared to the modified atmosphere. Uh, with the physical chemical properties, we did not see any advantage of disadvantage. So most of our differences were based on the microbial counts. So as a conclusion was just, yes, we can extend the shelf life of black drum using modified atmosphere. However, either combination of gas will result in the same shelf life. In this slide, I want to talk to you a little bit about convenience and quality. So we have here crab meat, and usually here in Louisiana, crab meat is marketed in tubs, which is convenient. It just have a headspace, but you cannot actually see through the package. Then here we have vacuum pack, but if you remember how I told you how crab meat is very sensitive to vacuum pressure, so if you put it really tight, you're gonna have all these exudate or drip loss that it can result in a dry product if you are not careful. And then we have here modified atmosphere where the tray allows a little bit more exposure of the product to the eye of the consumer so it can examine better. But we do have the headspace. So it will depend what is the application of the product that you want to use and what is the type of package that you want to use. The last technology that I'm going to cover in my presentation is the control atmosphere systems. These are used during bulk transportation, and even though there are many systems available, the one that I'm gonna talk here uses an ultra low oxygen levels of less than 1,000 parts per million and a high carbon dioxide around 60 to 75%. To use this technology, product must be chilled to -1 degrees Celsius before packaging. And the basis for the extension of the shelf life using this system is that a high carbon dioxide and proper refrigeration will reduce microbial growth, and the ultra low oxygen and proper refrigeration will prevent the fat oxidation and color change. In a presentation from Larry Bell, he shared this early commercial scale work done in 2011 in Norway, showing the remarkably fresh quality of farmed salmon fillets stored in ultra-low oxygen and high carbon dioxide stored at -1 degrees Celsius. They actually were able to accomplish with controlled atmosphere system a shelf life of over 50 days compared to the 15 or less days that can be achieved with an oxygen permeable packaging. In this picture, I want you to see how similar the color and freshness of a just fillet salmon compared to a 39-day-old salmon fillet. In this graphic, I want to make a comparison on the difference of freshness using a controlled atmosphere system to a non-reduced oxygen system. So using a controlled atmosphere system allows you to use ocean freight to transport your product to your final destination, compared to the non-reduced oxygen packaging where you had to use air freight to make it there as quick as possible. The interesting thing here is that with a controlled atmospheric system, you can achieve to have freshness of your product even to 9 to 10 days at retail once you reach your destination, compared to the non-reduced oxygen packaging where you might get 2 to 6 days. The takeaway here One is that you will have a reduced carbon print using the ocean freight and also probably less than half of the cost. So even though you will need to transport higher volumes, you will have a benefit on a longer shelf life of the product. Until now, I have talked about all the great benefits of reduced oxygen packaging and how it can extend the shelf life of your seafood product and its freshness. However, there are some limitations to this technology, and the main one possibly is safety. According to the National Advisory Committee on Microbiological Criteria, in the absence of oxygen, non-pyrolytic Clostridium botulinum present in seafood products can grow with temperatures as low as 3.3 degrees, resulting in the formation of its deadly toxin. If you remember from earlier in my presentation, refrigeration is usually at 4 degrees. So if you store a seafood product long enough in the refrigeration, can result in the formation of this toxin. So the U.S. Food and Drug Administration had suggested different guidance to prevent the toxin from forming. One is the use of temperature control as needed to ensure the growth of the bacteria. Once the product is out of the manufacturer's control, this can be achieved by using time temperature indicator devices. The FDA also includes in their guidance the option of freezing reduced oxygen packed product immediately after it's packed, with instructions on the label to open package during thawing, thaw under refrigeration immediately before consumption, and not refreeze the product. However, to be able to still get the benefit of the shelf life extension of reduced oxygen packaging, you can use these in bulk containers for shipping and storage, in which the temperature can be strictly controlled before it's sold to the consumer. In conclusion, reduced oxygen packaging offers a great opportunity to the industry, extending the shelf life of their product that will result in a reduction of the cost of distribution and the carbon footprint. However, safety implication limits the use of this technology. Reduced oxygen packaging is probably better recommended for frozen products, or if it would like to be used for fresh product, it's advisable to use it in bulk product during shipping and storage, and then the product can be transferred to an oxygen permeable packaging for retail and distribution. With this, I conclude my presentation, and I would like to thank Laitram Machinery for the invitation to participate in their webinar series. I would also like to thank you for your attention. If you have any questions or you would like to have more details about the information I just shared with you, please feel free to contact me to my email or visit my website that is shown at the bottom of the slide. Thank you very much. Have a good day.